Let's talk about integrating Hadoop with real relational databases. We talked about using Hive earlier, which is making a Hadoop cluster look like a relational database, but it isn't really one under the hood. However, you might have an actual relational database, such as MySQL, that you want to import or export data to or from your Hadoop cluster. And we'll talk about a tool called Scoop, which lets you do just that. So if you're new to the whole world of MySQL or relational databases in general, just a quick overview. MySQL is what we're going to use in our examples here. And it's just a very popular and free relational database. Popular and free, usually a good combination. Usually something like MySQL will be monolithic in nature. So it's going to be installed on a single server that has access to, a giant hard drive. So that means you're kind of limited in what you can do. It's not distributed across a cluster, but because everything's local, something like MySQL is appropriate for OLTP, online transaction processing. If you need to very quickly get an answer back from your database, a tool like MySQL can do that. So sometimes you want to export your data into something like MySQL. That can be a very useful thing to do because it allows faster access to your data after you've chugged away on it on your cluster. And you might have existing data as well that exists in a huge MySQL database today, and you want to import that to your Hadoop cluster so you can execute more complex queries on it across a cluster. So there is a tool called Scoop that lets you do that. Cute little name, SQL and Hadoop kind of squished together. I like that. And the way Scoop works, it's made to handle large data sets and import or export them to your Hadoop cluster. So it actually kicks off a MapReduce job to do this. So the way it works is when you start Scoop, let's say that you're trying to the correct terminology would be exporting data from your database into Hadoop. This is what's going to happen under the hood. It's going to kick off a bunch of mappers. And it's just going to be mappers because all we're doing is moving data and transforming it from one place to another. There's no real reduce going on here, right? And all these mappers are going to talk to your HDFS cluster on your Hadoop cluster and populate a big old table on HDFS, which is just a giant text file, basically, comma separated values or whatever format you specify. And from there, you can use tools like Hive or Pig on it, right? So very cool. And I should point out, too, that this bottom step here, going from the mappers to HDFS, is more parallel than it looks. So remember, HDFS itself is distributed across your cluster, and it tries to keep things local. So each individual mapper will probably be talking in part to a block of HDFS that's on that same host. So it's not really the bottleneck that it appears to be here. So anyway, very powerful way of distributing data. And, as with any MapReduce job, there's going to be a good amount of overhead involved in just spinning that job up and kicking it off. So don't expect it to be, the most efficient way of handling imports and exports on small data sets. It's really meant for larger pieces, larger data sets. So let's look at the actual syntax here. Scoop is just a command line thing. So you can kick it off from, a script or a cron job or something like Oozie if you want. And all it does, it's pretty simple syntax. So let's say you want to import data from MySQL to HDFS. This one line would do that for you. So let's break this down. We're saying scoop import, saying that we want to import data into the cluster. We're going to connect to a given database instance. So in this case, it's going to be the JDBC connector on my MySQL database that's running on the host localhost. And it's going to connect to the database named MovieLens. Okay, this is all just an example. So obviously, if you're actually using this for real, you'll need to change all that to actually point to your actual database host and your actual database name, right? We also need to explicitly give it a driver in some cases. So just to prevent some problems, we're going to say explicitly use the com.mysql.jdbc driver. And that's just going to ensure that this works properly on my Hortonworks sandbox environment. You can use other drivers, of course, if you need to. And on some setups, you can just leave that driver argument off entirely and the default should work. And finally, we're going to specify the table that we want to actually move out of MySQL into HDFS. So let's imagine that we have a movies table that contains all the movie names and movie IDs that will tell us what we're interested in actually getting out. So assuming you have the proper permissions set in MySQL for Scoop to actually talk to it, and we'll show you how to do that in a moment, this one little command would actually suck out the entire movies table out of your MySQL database and copy it onto your HDFS cluster as just a bunch of flat files. Now you can also add a -m argument that says how many mappers do you want to use. So we're actually going to add something to this -m1 when we actually run it on our sandbox because there's no point in having more than one mapper when you only have one server. Now let's say you actually want to go straight into Hive. You want to skip that intermediate step of actually dumping files to your HDFS cluster and you just want to create a Hive table. That's very easy to do. All you need to do is add this one little parameter at the end called Hive import, and that will create a new table in Hive called movies that contains your movies data. So very, very smooth integration with Hive for importing data from MySQL or any JDBC connected relational database really into Hive directly, and we'll show that as well. Another cool thing about Scoop is that you can do incremental imports. So there are a couple of other parameters too. Check column, which is basically a column that contains something like a timestamp or a sequence number or something like that. And then you can provide a last value argument as well that will say, I only want to import data where this column's value is greater than some given value. So this lets you do things like import a database, keep track of where you left off, right, in terms of some sequence number or timestamp. And then the next time you run Scoop, you can put that previous save value into your last value and only get new data that was added since the last time you tried. So this is a mechanism for actually keeping your Hive table in sync with a relational database over time. Pretty cool stuff. Also, you can go the other direction. You can export data from Hive into MySQL, and here's how that would look. So a lot of the same arguments here. We're going to say Scoop export instead of import this time. Again, tell it what database you're connecting to. Our -M1 here is just saying I only want one mapper, so if you're running this on a real cluster, you wouldn't use that. We specify our driver again just to be safe, and we specify a table in MySQL that this data will be saved into. And you do need to make sure that table already exists, so Scoop is not going to create that for you. You need to create a table with the appropriate columns ahead of time that matches up with whatever data is in your Hive table. And then we just specify for the export directory the actual directory where Hive is storing its table. And remember, under the hood, all Hive is a layer, like it's imparting a schema onto a file on HDFS. So if we just give it a path to where that data lives in HDFS, and for a managed table in Hive, it's going to be under apps Hive warehouse, at least on Hortonworks. That's where all you need to do. And finally, we need to specify what delimiter is being used for the input fields in the Hive table. By default, that will be ASCII value 1. Okay. So that's all there is to it. So let's go do it. Let's do this. So what we're going to do is actually log into our Hortonworks sandbox environment. We're going to import some MovieLens data into a MySQL database, and fortunately, Hortonworks comes with MySQL already installed, so there's not much we have to do there. And then we'll do all the stuff we talked about. We're going to import movies from our MySQL database into HDFS, then we're going to import it directly into a Hive table, and finally we'll import the data back from Hive and into a new table in MySQL just to show you that this stuff does in fact work. So let's give it a shot in the next lecture.